And we are on. Well, I'd like to welcome you to another episode of Chilefornia Talks. Just as a reminder, this is the space that the Chile California Council has designated to talk about people's Chile California stories and how the two regions interact. I have the distinct honor to be joined today by two of our Chile California Council members, Komal Dadlani and Eduardo Bendek. We're in great company, you guys, and you've already had really nice, engaging conversations. So I'm just going to briefly introduce you. Komal Dadlani is a biochemist with a master's in science from the University of Chile. And in 2003, she founded something amazing that I've only just now started to learn about, which is Lab4U. And basically, and of course, Komal, you're going to tell us more about this, I hope, but the idea is to democratize how STEM is taught to kids, how kids interact with it, and the access they have through devices that we all have around the house, which is amazing. So welcome, Komal. And also, Eduardo, he's also a director for the Chile California Council, which is obviously a big plus on our side. He is a scientist and an engineer who's worked for NASA for over 12 years. And he's part of the team that designed and built the coronagraph instrument, which hopefully you're also going to tell us more about because I don't personally know. But what it's meant to do is search for planets around other stars, and it'll be launched aboard the Roman Space Telescope. So again, we're in great company. The dynamic in this episode is going to be Komal will interview Eduardo, and then Eduardo will interview Komal. So welcome, you guys. Thank you so much for making the time. And you're on.
Wonderful.
Thank you very much, Daniela.
Thank you, Daniela. I'm excited for this conversation because I'm getting to speak with you, Daniela and Eduardo, and I'm a big fan of Eduardo. Eduardo, thank you for being such an honor to speak to someone like Eduardo, who's a scientist and engineer working at NASA. Just to kick it off, because our previous conversation, we spoke about fascinating things like exoplanets and space mission and many other things. But just to kick off, can you share a little bit about your story? You know, how about your journey from Chile to NASA? What inspired you to pursue a career in space exploration?
Yeah. Hi, Komal. Hi, Daniela. Thank you very much for setting this up. It's a pleasure to talk with you and to share a little bit more about what we do here at NASA. So answering your question, well, I grew up in Chile, and since I was a kid, like since I have memory, I always dream about airplanes and rockets and big ships and any big machine that would be impressive. I would just be crazy about it. Actually, I remember that when I was I don't know, 10 or 12, there was an aircraft carrier coming to visit Valparaiso, and on its maiden voyage to the Sixth Fleet in San Diego. And then I didn't know what to do. I really want to visit it, and someone told me, write to the embassy and say that you want. So I handwritten a letter. Imagine, I was 10. This was the 1986 or something like that. So I handwritten a letter saying I would love to visit the aircraft carrier, blah 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 blah. And I received invitations to go, and it was just like a dream. Like someone at the embassy listened to a kid 10 years old. And so in my life, I've been always pursuing dreams and things of that kind that really have enabled me to make progress on my career and to dream bigger. Then I always done all kind of experiments to test all kind of science concepts. I remember things from making hydrogen for balloons all the way to radio control planes and toys, and even superconductors and getting liquid nitrogen to make it work. Always experimenting and fascinated about it. So I think it has been, and that trajectory took me to the engineering school in Chile at Universidad Católica. And then I did in parallel minor in astrophysics, and I started to like astronomy a lot. Then I I moved to the European Southern Observatory. I worked at the Parallel Observatory for 5 years. Um, but always I keep the idea of I wanted to do more science and space missions. And then it happened the opportunity to start up a company. So I did a startup with some friends on a telecommunications company, which I worked for 5 years on it. But at the end, I really wanted to do something else. So I moved to the US to do my PhD in optics, in the optical design, because there are a lot of astronomers and there are a lot of mechanical engineers or electrical engineers, but there's not many people studying optics, and optics has become a key technology, like on everything that we do on today's life. If you look from the camera on your phone, the flash on your phone, the screen, the display on your phone, all the telecommunications, everything is about works with optics. And then for astronomy, optics is essential. That's what, like the big telescope, that's the way that it works with optics. So I decided to specialize on that, on learning how to build telescopes, and from the optical point of view, which is the essential part. The mechanics just hold the optics. The astronomy uses what the optics generate. So and then during my PhD, I met people working, some professors working for NASA on projects sponsored by NASA, and they invited me to work for them. So I started to get involved, and then after I finished my PhD, I was awarded with the NASA postdoctoral program fellowship, and I came to NASA Ames to work on designing a space telescope for exoplanet detection. So that's kind of the story in a nutshell.
Oh, wow, Eduardo, that's fascinating. How from your career in Chile, then you went into optics, which is fundamental today for space exploration. You PhD, and then got into a postdoc with NASA Ames, and now you're at NASA Ames. You're truly like a rocket scientist, right? Really, 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 really inspiring. And you mentioned it briefly, right? And working now on exoplanets. Any specific projects or mission that you're currently working or are involved in at NASA?
Yeah, so I've been working on many missions, some of them at the design level, some of them that are flying. And I think the key motivation for me has been to find Earth analogs. So we know of more than 6,000 planets. So we have detected more than 6,000 planets.
Yeah,
But
just for our audience, Eduardo. So you're trying to look for Earth parallels or like similar to Earth. Can you explain a little bit more?
yeah, imagine when you look at the sun is a star, okay?
Yes,
And the sun has 9 planets orbiting it. So if you look at night the sky and you see billions of stars, all of them they have planets. The point is
exactly.
that it's not easy to see them. So the technology that we work on is on enabling these telescopes to be able to detect those planets. And there are two kinds of detection. There's the indirect detection, in which you don't actually see the planet. What you do is you see the impact of the planet on the star. So you just see the star and say like, the star is moving, or the star is getting a little bit dimmer, so there must be something there. Yeah. And there is another technique, which is direct detection, which actually takes the picture of the planet, and then there you go. Here's the planet. That's the hardest one, and that's what I'm working on being able to actually take an image of the planet, because the that's a holy grail. Because when you can take an image of the planet, you can also take the spectrum. The spectrum is the
Right.
colors that are coming, and that tells you what is the chemical composition of the atmosphere. And it gets very interesting, because at that point you can tell whether the planet has oxygen, whether there is chlorophyll, and those are indicators of life. So we are chasing for life. We're looking for life on a different planet. But the first step is to find those planets, and the second step is to characterize them. So that's kind of the passion. That's what behind all this work. And for me, interestingly enough, my passion has been Alpha Centauri. So Alpha Centauri is the closest star to Earth. Okay, so if you leave the solar system on a spaceship, you take the ride Yeah.
Yeah.
And then you say, well, let's select the closest destination. Like when you go Google Maps, where is the closest gas station? Yeah, you say, where is the closest star? Then it's Alpha Centauri. Now, Alpha Centauri is a complex system because it has 3 stars. It has 2 binaries that are similar to the sun orbiting around each other. And there is a 3rd star called Proxima Centauri orbiting farther away. Now, we have done indirect detection of a planet similar to Earth around Proxima Centauri. Yeah.
Oh wow.
So
So
we'll,
there could be life outside
well,
planet Earth and outside this solar system?
not quite, because that planet
Ah,
is
come
around
on, Eduardo.
Proxima Centauri, which is a brown dwarf. And brown dwarfs, they have a lot of radiation coming out of them because, well, for several astrophysical reasons, but the amount of radiation would sterilize everything living on the surface of the planet. And also there is it's very unlikely that there is an atmosphere. But the good news is that the stars, they have planets. So now we're chasing the other 2 big ones, the Alpha
Right.
Centauri A and B, which are similar to the sun, and those are benign, and they don't have this level of radiation. So if there's a planet there, we'll find it. Now, guess what? They're the closest star to Earth, but still we cannot see planets there.
Right.
And that's because our technology is not ready to do that kind of detection. So my passion here is to advance the technology to be able to see planets around Alpha Centauri. And the mission that I'm working on, which is the Roman Space Telescope, will carry an instrument that will be able to do to search for an Earth analog around Alpha Centauri and tell us whether that planet is there or not. Now, from demographics, we know that there is at least 50% probability that the Earth has a sister there, an Earth analog.
Wow,
So
that's amazing. So this Roman space telescope that you're working on, you want to find this Earth analog that you think that there's 50% probability that we have a sister Earth?
yeah.
Okay, amazing. And
My mind is blown.
yeah, so
So
I now I
imagine,
am
Komal, imagine, picture this: like you are at dark sky at night, camping somewhere in Patagonia with this beautiful sky, or in the Atacama Desert, and then you can point to a really bright star on the sky, and you point to it, and I can tell you, look, that star has another planet like us.
wow. I
And
love it. I love it. Yeah, you mentioned watching the stars and Alpha Centauri, and you mentioned one of my favorite places on Earth, which is Patagonia. And thinking about the relationship with Chile and California and NASA, why observing the Alpha Centauri and finding this Earth analog? Why do you think it's important to get Chile involved and thinking about space mission and exploration? What plans do you have for Chile, and why would an exploration plan in Chile be interesting?
well, here there is a huge synergy, because while the Roman Space Telescope will be looking for this planet in visible light, meaning
Yes.
like light that we can see with our eyes, the European Extremely Large Telescope in the Atacama Desert will be looking for signals of this planet in infrared light. And then you can tell me, well, but what the infrared tells you? The infrared tells you the temperature of the planet. So then they
Wow.
will be able to know the chemical composition, the atmosphere, and then also the temperature. So the Atacama Desert, it's an incredible laboratory and location for ground assets that complement what we do from space. And I think that Chile has a key role on doing these observations. Chilean astronomers can ask for telescope time, and we should work together on those synergies. And there is a link between Chile and California, because here we are doing all this space-based effort, but we need ground support, and that ground support can be done from Chile. Now, also, there is a big connection between JPL. I worked for 5 years at JPL, and at JPL, the Jet Propulsion Laboratory, we built rovers to go to Mars and other planets in the solar system, and those can be tested in the Atacama Desert. Several of them have been tested there, but we need always the support to do those testing and verifications. So Chile can play a big role as an analog, meaning like as a place similar to to these destinations in the solar systems where we can test and develop technology.
Yeah, these multidisciplinary teams with multi-country efforts are important as we move forward into finding life in other planets and finding Earth analogs. And this collaboration is so important, as you mentioned. And think about your broader goals in space exploration or scientific discovery. Like, the contribution, when we think of the contribution of your work with Chile and California and finding, sister Earth analogs and sister planet, how does your work contribute to NASA's broader goals in space exploration or scientific discovery?
Well, I think that the one of the NASA has three big questions. Yeah. So one of them is, are we alone?
Uh-huh.
So we're trying to answer the question if we are alone in the universe or not. If there
Are
is
we
life.
alone? Are we alone in
Yeah.
this
Yeah.
universe?
I mean, picture it like, you mean like
What do
from
you think? Like, regardless of what you have observed, what do you think, Eduardo?
well, but before I tell you what I think, let me tell you like something else. It's like, we study history, we learn about the all kind of colonization and expansion of empires on earth that went, the Romans, the different empires, that there's so much history on earth. But when you go and look from a spacecraft that is flying, then you look at Earth and it's just a dot. Like when Voyager looked back to Earth from Saturn to take a picture of Earth, it was just a pixel. So when you think of us, a humanity that is so complex and there's so much going on, well, it's just a pixel. And we have been there and enclosed, isolated, and there's life there, and period. We don't know anything else. We don't know there's this vast space with billions of stars and millions of galaxies, and we don't know of any other source of life. So now my answer is, or my belief is, that there is life. There is life. The problem is that the universe is too big, and the time to travel and to sparse, like there's too much empty space. So the time to travel and to communicate is extremely long. And I also believe that civilizations grows and decay and disappear. So I think that the likelihood that you encounter in time and in space another form of life is so low that, well, we are alone. Now what we're doing is searching for that possible civilization without needing to traveling there, just observing other planets.
Yeah. Wow.
And there is a discipline here at NASA that is called technosignatures. So how it would look signatures of an advanced civilization, what we can observe that will tell us that there is an advanced civilization, not only life. But that's a little bit beyond of what I do. What I do is mostly looking for life, looking for sign of oxygen and chlorophyll. That's kind of what we're working on.
Yeah, you're finding that Earth analog. But I still like the techno signature. And talking about technology and techno signature, what are you worried about? Thinking about, the SpaceX is very popular, and when we were discussing about what will happen in the next 15 to 20 years, when we speak about satellites, and what are you worried about when it comes to space and how it could impact our heritage, our skies?
Well, so I think that what I worried is that we're going to lose some experiences that were unique, and kids and future generations are not going to know what it was. And I think I will change a little bit the essence of the human being. Let me backtrack a little bit. 20 years ago, you'll have cell phone reception on limited areas, and if you, as soon as you go a little bit outside the city, there was no reception. You go to the mountains and there will be no reception, or you go on a plane and it was this feeling like, I'm going to take an intercontinental flight and it's like no internet, I can relax, that's fine, I don't have to
Not
answer it.
anymore.
Well, not anymore. And now with the Starlink and other constellation, this is like, it's over. Like, for example, at Burning Man, normally this festival in the desert, there is no internet reception. Now most of people have Starlink, so you can go and connect with your phone, which is like you say, well, it's beautiful, it's great, it's a great service, but also kills this hope of peace where you say, I can disconnect. No, now you cannot disconnect, and in the future would be worse. You'll need to go into a abandoned mine and get under thousands of meters of rock to be able to truly disconnect and to experience the feeling. So the point that I'm making is that as technology advances, we also lose something, and what we lose is the way of living that the humans evolve with. So we evolve with a limited ability to connect to other people. We evolve in a way in which we live in communities, and communities will grow and develop by itself. So this constant connection that is ubiquitous, that you don't have this small relief where you say like, yeah, here I have the right and I have peace of mind that being disconnected is going away. And now that,
but everything has its pros and cons, right? I mean, you want to democratize access to internet, and Starlink, for example, is providing that, but at the same time, you're losing other aspects of that disconnection, if you will.
yeah, I mean, everything has its pros and cons, but I'm like pointing out the con because everyone is aware of the pros. So I'm just saying, like, there is something that we're missing here, and it's very intangible, and most people don't see it. My other concern is that there will be, I don't know if you have seen um, the series in which the Earth become like just a techno planet, and it's called Trantor. Yeah. So then by Isaac Asimov, and then in that case, what happened is that the Earth just become a planet that is surrounded by all kind of systems, and you don't have anymore this experience of Earth where you can see the sky and the stars. You have satellites flying, you have all kind of structures going around doing things for Earth. So there is value on that. There is value because
you're concerned of the light pollution that we will have and the satellite pollution that we'll have in the next 15 years.
yeah, I mean, you can go to Patagonia, go to the Atacama Desert, and you look at the sky and you see a dark sky, you see stars, you can see the Magellanic Clouds. Soon, you're going to be covered with trails, and you'll see stars, but you'll see satellites going around, and the satellites are like more stars moving very fast on the sky. So it's not like you see the big satellite; you just see the things moving. But think about it: you lose forever your ability to see a dark sky, a quite dark sky, and I think that's very profound. I think that's very profound for our kids. I mean, I have a daughter, a 3-year-old, and when she will be 15 or 20, she won't be able to see the sky anymore. I mean, to see a clear sky, a sky without sunlight.
Yeah. And thinking about Chile and California, how do you think that impacts our heritage, and do we have to do something to look after that? Just as we have strategies for conservation in nature, should we have strategies to look after our skies?
Yeah, I think that there is a lot to do.
Public policies.
Yes, absolutely, because Chile has an incredible asset, which is the Atacama Desert, that is being compromised now by this development of space and will be more and more damaged. So this is really like having a very pristine lake, and then you dump water in it, and it's not pristine anymore. So the impact for ground-based telescopes is huge, and basically you have these private constellations that are flying over the Atacama Desert, and they are impacting the quality of the sky, and Chile is not getting any return of that of those operations. So to some extent, it's our sky. Now, legislation is not very clear. There is no regulation about flight level 6,000, so 60,000. So above 60,000 feet, you don't have any legislation to say, okay, you're flying over my territory, so you're like in Chile. No, it's not the case. But ESO has been working with SpaceX to make the satellites dimmer, and they have had a huge success of making them dimmer. but now there are more and more constellation being launched, and those guys are not like making their satellites darker. So while SpaceX is working with ISO and other organizations, many others are not. And then it's difficult to clean up. Like you launch satellites and some of them decay, but if you go out to higher orbits, they can be there for 25, 50 years and they just stay there. So I think that there's a lot of policy that Chile can work with California on checking for maintaining dark skies. California also has big observatories, so there's Mount Palomar and the 5-meter telescope, and there is an interest of California to maintain their assets in Hawaii because University of California has telescope in Hawaii to maintain the sky dark. So yeah, there is a lot of policy that can be done.
Wonderful, wonderful. Last question. As we think about the future and we think about the work you're doing, what are your hopes for the future when it comes to, be it public policy, space exploration, as we find life in other planets, and when we talk about this international collaboration? What are your hopes for the future?
Yeah, my hope for the future is that we soon find an Earth analog around Alpha Centauri, and it's so close that really boosts the interest of the community on like answering after the question, after you know that there is a sister Earth sister in the closest star system, and knowing that we can develop more instruments and more telescopes to be able to tell if there is life there. Um, then I hope that that could unify humanity a little bit on a quest of like, okay, now we have a common goal. Like we want to understand. Maybe I'm making this too grandiose and people won't care. Not sure.
I'm already fascinated.
I care. I'm
But
in.
but it's a little bit like in the movies where like
Or philosophical, right?
yeah. So my hope for the future is like this can unify a little bit humanity towards a goal, and imagine then we find signs of life, and then we unify even more towards like understanding what kind of life it is. Can be enemy, can be friendly, can how developed it is. Let's contact them, and all that story that becomes science fiction rapidly, but it could not be science fiction. So my
Right.
hope is that, and also I think that my hope is that we go to Mars and we colonize Mars and we kind of get we expand in the. I agree with Elon Musk on like becoming interplanetary species. I think that would be fantastic. I do disagree a little bit with colonizing without just going there. I think that we have to be careful. We have to preserve the planet and not just drop trash everywhere. So I think that we have to be careful on that
I
sense.
mean, yeah, be more organized and careful. Absolutely. As we think of humanity in the future, of this universe, where we are a little, we are a pixel in this
Yeah.
vast universe, which gives us perspective on life and the impact we have, be it Chile, California, or the entire world, or the universe. Eduardo, it's been fascinating to speak with you and learn more about your work. Daniel, also thank you for hosting us in this Chilefornia talks. I could
Thank
talk
you,
to
guys.
Eduardo for hours and hours.
Right?
Absolutely, absolutely. This was fascinating. Thank you,
Yeah.
Eduardo.
You're
Invite me
welcome.
to NASA.
Huh?
Well, invite me to NASA. I want to. I
Yeah,
want to know more about Alpha Centauri.
you
Well,
should
on
come
that
on the.
end, I do believe Eduardo has some questions for you, Komal. So now
Yes.
Oh no, but
give it
I
over.
was supposed to ask Eduardo the
No, no,
question.
no. Now you have to tell us what you're up
Uh,
to. So
Yeah,
take
yeah.
it
So
away, Eduardo.
yeah, so come on. I've been following your project Lab for You, and it's fascinating initiative. I think that after when many times I play with the phone and with the sensors, but I never thought about doing something for other people. I would just play for myself and like, but I didn't have like the creativity to say this can be for everyone. So, can you tell us a little bit how Lab for You started and how this evolved from curiosity to the the company that you have now?
Yeah, no, thank you, Eduardo. As you were talking about Alpha Centauri and your projects, I was already thinking of some experiments that we could do with Lab for You to help students learn more about space and the universe that could give us perspective and develop scientific literacy. So Lab for You started because I wanted to solve a problem in schools where schools don't have lab and budgets are limited, and I truly believe that talent is universal but opportunities are not. So how can we inspire more and more people to love science and see the world around them and experiment, and understanding that technology is a means to an end, and not the end itself, where we wanted students to learn. We thought, why don't we use smartphone sensors that are already accessible to almost everyone, where people buy smartphones before buying computers in mobile first economies like Latin America, where resources are limited. So why not leverage the built-in sensors of smartphones, like the accelerometer, the camera, the gyroscope, the microphone, which is the sonometer, where you can send an audio note of WhatsApp, but we can actually use the sonometer for science experiments. So what we're basically doing is we're leveraging all the built-in sensors that smartphones and tablets already have, and we're designing fun and engaging labs so that students around the world can experiment and have a lab in their pockets. And now with AI, we're integrating AI to build more and more experiments for high schools, for universities, for technical students in different STEM careers.
So Kamal, when you say like that, seems so easy and so obvious. Like, yeah, why? Like,
Right?
so
Like,
so.
oh,
But
let's
I
just
think
do it.
I think for entrepreneurs there is a big challenge, which is this is not just about idea. This is also about timing. Because if you try to do what you're saying when smartphones were very basic, it wouldn't work because it would be
Right.
too basic. If you wait too much, a competitor would already have done it before you. So, like, how this idea pop up, when it pop up, and how did you decide that was the right timing? Did it came just from you, or you were working with
Yeah,
other
no,
people?
that's great question. So, when I was in university, Universidad de Chile, this was 11 years ago. My first idea was to build hardware, like physical labs using Arduinos with sensors, right? The challenge with that is that it was expensive and not scalable. But
Yeah.
we're talking about 2013, everybody was starting to use, we were switching from the BlackBerry. I don't know if you remember those, but
Yes.
we were switching from the BlackBerry to the more
Oh,
basic Androids, right? So there was already a transition happening in people's life and in telcos, where people were actually, having the iPhones, and the Blackberries were going outdated, and the Android phones were being more massive. And these Android phones had basic sensors for games. So we were just like thinking about games where you could, drive a car using the accelerometer. So from the idea of, physical labs, how did we jump to the leveraging smartphone sensors? It took us a while. I mean, it was not something that popped out directly. We did a lot of research development, and collaborating with others, and my co-founder Alvaro, also a student at Universidad de Chile. And I was doing the experiments with the hardware, and he was like, hey, but we can actually use the phone, maybe to integrate the hardware and the phone.
Yeah.
But then it's like, hey, but the smartphone also has sensors. So we started testing different sensors and actually building a digital colorimeter with the camera of the phone, where through analysis of different pixels, we could calculate the concentration of a colored solution using computer vision, and not only an Arduino sensors, but actually the camera of the phone. So it was a process, and I would say it took us 7 years to be relevant for time to market, because there was a lot of R&D. Phones were not as massive and not as powerful 13 years ago as they are today. And I would say that the pandemic really boosted and gave us the time to market, for more major adoption especially in Chile. And we did some pilots in California, in Menlo Atherton, in Berkeley, with some students comparing, schools in the US and schools in Chile. So I would say it was a process. It was not a magical aha moment. It was like many moments year over year. And as you know, it happens in research and development.
So as of today, you already are 100% phone platform. No, you don't have separate hardware for experiment.
Correct. We're 100% phone platform. You don't need external hardware to run experiments. What we use basic materials that students can access. For example, a plastic bag where you
Yeah.
put the phone in a plastic bag, you connect it to a spring, and you can analyze Hooke's law with spring constant
Yeah.
in a harmonic motion with the accelerometer. So we use basic materials to complement the lab experience because we believe in hands-on learning and active learning and inquiry-based learning, where experimentation and inquiry is important. And now we're integrating AI so that students can have a tutor in their app. They can design, teachers can design new labs with AI and our tools, and that maximizes the potential of what education technology could be for the future.
Wow, that's so cool. And what do you see the path forward for the future? How do you see lab for you evolving?
Yeah. So what will happen now with AI and the convergence of AI with other technologies and the power of quantum computing moving forward is that we will have the potential for adaptive learning and personalized learning. So different students today, what happens is one teacher, many students. This is what we're teaching, and maybe your learning speed is different from Daniela's learning speed. My learning speed is different. My styles are different. So now we will be able to have personalized learning at massive scale, where adaptive learning and STEM learning will be easily accessible for everyone, because the jobs of the future, more than 70% of the jobs of the future will be related to STEM, science, technology, engineering, and mathematics. But very few students decide to pursue a STEM related career, and very few women decide to pursue a STEM related career. So what we're doing is, how can we inspire more students to engage in science and technology, to engage in STEM, so they can be the future builders and of technology, and not the consumers of technology, but the builders. So personalized learning, adaptive learning, AI, and just experimentation as a whole to democratize access to quality STEM education is what I see for the future.
Can I
Wow,
pop
that's
in
so inspiring.
just a little bit? It's amazing what you're saying. Sorry, Eduardo, because it's, imagine how many scientists we lost because they were not going as fast as maybe their teachers were presenting the material. That's fantastic.
Yeah, no, and we learn by doing. It's not
Right.
about understanding the formula F equal ma, but understanding the relationship of mass and acceleration and force through an experiment where you come up with the answer while you learn by doing.
Like what Eduardo showed us about Peppa Pig's shadow.
Yeah, exactly.
Amazing. That's so cool.
Yeah,
So,
but
you know,
yeah, we're hopeful for the future.
this
Great.
is so interesting because I think as machine learning and language models take over and start to give answers to us, I think for us humans, the critical role will be to give context.
Yes.
So and to give context, we have to have a deep, profound understanding of what physics is. And I think that what you're doing, it gives people that, and I think it is an unvaluable tool.
Yes, yeah, absolutely. And that inquiry, that critical thinking, is crucial now more than ever, as we help students think and design and develop skills, with through experimentation and hands-on learning.
Well,
Absolutely.
I hate to rain on this parade because it's been fascinating, and we should think about another episode with you two. But thank you so much. If you guys want to share anything extra or
I just would like
guide us
to
to your projects.
just would like to thank you, Komal, for the time and
No,
for the
thank
great
you,
questions.
Eduardo.
Great
I-
interview.
Absolutely. I mean, I'm excited about the future and finding, an Earth analog
Right.
where there's 50% chance to find a sister
Our
Earth
sister.
outside and giving us perspective about human potential, like our capacity to explore. And that's why I believe so much in education as well, because as a race, as human race, we have the potential to explore space and at the same time understand that we are a pixel in this vast universe. So the conversation with Eduardo gives us that perspective, and here we combine Chile, California, science education and space exploration in this Chilefornia talk. So thank you, Daniela. Thank you, Eduardo. And looking forward to the next conversation.
For
Yeah,
sure. Thank you
same.
so much. Thank you both. It's been awesome, and I hope we can do a follow-up.
Yeah,
Absolutely.
we'll talk about some other contingency topics later.
Or we can interview someone, the three. No, I'm just kidding.
Yeah. Okay.
All
Have a
right.
good
Take
day.
care, guys.
Absolutely. Bye-bye. See you.
Bye-bye.
Bye.